Okay, so now we come to the last speaker of today. Let's welcome all together Adrian Fleck from Germany.
Hello, my name is Adrian Fleck, and as you can see, my project's name is also Fleck Protect. This has obviously to do something with my surname. So I'm the last presentation, so I make 1 hour. So no joke. Also 5 minutes. Now I'm going to tell you something about what is Fleck Protect, and it's did I get something mixed up? Very good. Very good. Now it isn't working anymore. Perfect. Let's see. Okay, this is weird. So I have to do it like this. It's okay. I prepared a nice video for you, which summarizes my project quite well. Basically, I invented a new kind of body protection made out of a fluid, not a normal fluid, a non-ionic fluid. And you all can, if you're familiar with non-ionic fluids, if I steer it slowly, it goes very easy, and I try to steer it very fast. I need more energy. And the whole idea behind our project protector is that if you are in a normal situation, you can move as freely as you want. And if you are in a dangerous situation where you fall on the bottom and get an injury with your bike and something like this, the fluid inside our protector gets very viscous. And in a viscous fluid motion, you can dump a lot of energy due to friction in the fluid. And also you can spread the force better. And this is the whole idea behind it. And we realized it quite well. This is not the only thing we've done. We invented also a lot of machinery to test our protector. The video is sadly not here. There you can see all our machines we invented. There's a self-invented rheometer. It can measure viscosity. Then we invented a 3D surface measuring machine where a topography gets measured, and our own test device for our protector, how good the protector performs to other protectors. What was important for our project, and now I can come to the first sheet here, is that we've done everything by our own. We engineered everything by our own. We programmed everything by our own. And one of the biggest things was that we want to prove that it actually worked to put a fluid inside a protector. Because many companies told us it's impossible in long terms, and that kinds of stuff, and we prove it, that it's possible, and even with a rather complicated non-ionic fluid. The scientific work behind our project was also very important for me, that we prove every step we had in our project, and also the enthusiasm for science. So, last sheet. It's a little bit weird now because you don't have the connection. On the left, you see pictures from a measuring, and the measuring works like this. You have our protector onto a surface out of styrofoam, and you let fall something out. You let fall something onto the protector, and then the styrofoam gets deformed underneath the protector. And this deformation tells us many things about our protector, how good it performs, what we could change internally inside of the protector, and what could we change on the fluid, on the start viscosity, the end viscosity of our fluid, and things like this. And out of the measuring device, we get this raw data, and then we had another program to interpolate this whole data to get a cleaner data. Then we took all the important values out of the data and compared them to other data we took out of other protectors. And we came to the conclusion that yes, our protector is better or more protective than normal protectors, and it's more flexible than normal protectors, and this is a quite good thing. So what I've planned for the future. Now this is working. At the moment we are developing bullet and step-proof variant for the police in Germany. We hope it will function. We use a different fluid and different fibers and everything like this. And yes, I hope it will work. So this was my presentation, sadly without video. And I hope you have some question which I can answer very quickly.
Great, thank you for your presentation. Okay, there's already one question. Great.
Does the protector protect your whole upper body, including the arms?
Yes, because there were the slides missing. One slide is missing actually. You have it, yes. No, it's only for special regions. It's one part for knee or for elbow, and you can put it in your jacket to protect this special region. For the police thing we are now doing, it's a whole body protection, but it's different from, it's a little bit more heavy than the normal thing, and as a motorbike driver you want as lightweight as possible your protectors, so only at these places were important for you. So.
Well, for the police, how much heavier is it than normal protectors?
I can't really say it like this because you have better protection. You can make it thinner, and if you make it thinner, you're a little bit lighter, and at the end you're at the same weight as a normal protector. If you have the same, but if you have the same thickness, you are more protected, a little bit heavier, and yes, I can't really say it now.
Thanks.
Okay, is there any other question?
Yeah, are there other questions? Okay.
Hello, are you using, is this a carbohydrate-based non-Newtonian fluid, or is it
no, actually,
some synthetic that you've made yourself?
It's very funny. We use, actually, everybody knows it's starch and water, but it would be too easy, and it's way too easy because the mixture out of starch and water sedimentates quite fast and it gets moldy very fast and change dilatancy. Dilatancy is the special property of changing the viscosity when a force is applied. And we don't want this dilatancy change or the sedimentation and all of this, so we had to put other ingredients, chemical ingredients, into it to stabilize the whole thing. For now we are experimenting with bore acid and oil, non-Newtonic fluid for the bulletproof variant, but this is only at the first steps. We don't have one at the moment.
Okay, there's one more question here in the front.
Just curious, how thick would you have to make it to be bulletproof, completely bulletproof?
This is exactly like the normal vest is, but the problem is with bulletproof vests, they are bulletproof but not that really step-proofed. And our technique could combine these. If we, after each layer of aramid, normally it's used aramid, we make a thin layer of this new non-Newtonic fluid, then aramid, non-Newtonic fluid, and then you have to keep it together because you can imagine that's also a problem, was a problem of our protector. We solved it. If you have a bag of fluid and lay it on the bottom, it's flat like you want it, but if you hold it up, the fluid wants to flow down, and you have to prevent it that it flow down, and this we may realize due to a 3D mesh, or in the case of the bulletproof vest, to special the 3D mesh inside of the whole vest. It's rather complicated, yes.
Thank you.
I think there was, one more question up there.
How far away are you from actually putting these on the market?
These for the motorbikers, there are a few companies are interested, and then at the moment we are talking with them to make the whole process mass producible, and it could go very fast if we solve all the problems of mass producing. I hope next year we will finish the whole project.
Thank you.
There's another question here in the front again.
What kind of other areas can you apply this protection fluid to?
Good questions. We are now thinking about for old people, also for people that had an injury or a broken bone, to stabilize the whole arm or something when they are transported from the injury place to the hospital. And it's for football, for every kind of stuff you need a protector, yes.
Thank you.
Is there any other question? Okay, then.
Thank you.
Thank you a lot. All right. Thank you. Okay, great. Okay, so this was the last speaker of today.